And other things like you wouldn't put a CHP or a biomass boiler or whatever on the same flue system as a premix condenser boiler. Moving on from that, so we've looked at all of our ventilation, our fluid, etc., and our legislation, and we're now looking at the system water, and really, I suppose the first thing really water treatment, and I'd probably say water treatment is probably one of the first things that gets neglected on a heating system. And yeah, it's great. You put the new boilers in; they probably get treated for the first couple of years, and then the contractor who's done it, he's now off the site, and he's no longer looking after it. Someone else comes in, and then we just don't know how to treat it or whatever, and it just gets a bit neglected. So really, when we're looking at what they're looking at the moment, so we're looking at replacing these boilers. Well, what existing water treatment have we got? Have we got any evidence of any water treatment? And if you can find some sort of logbook or whatever, brilliant. But chances are it's probably going to be probably won't find anything. What we would say is take a water sample, and what we do is we do things slightly differently as opposed to any other manufacturer. Would be that we could take 2 water samples. We can come to site and take those for you, and then what we do is we send those up to Hull. So obviously, because we've got our factory over up in Hull, but we also work together with Hull University. So what we would do is we'd take 1 water sample, give them to a water treatment specialist that we work with. We'd then take the other sample and take it to the university, and the students would then do a test on that to look at the makeup of that water. So now we've got 2 independent tests. Hopefully they come back saying pretty much the same. But based on that, then we can give guidance, or water treatment companies can give guidance on really what water treatment you should be using on that particular site to protect those boilers. But things like hardware as well, things like dosing pots, and as we practice to put those in, magnetic filters. I mean, water treatment companies have these kind of black magic voodoo kind of magnetic filters that they claim work. They can never tell you how they work, but they do work. So yeah, put those in. Plate heat exchangers. I mean, we're seeing that more and more now. We're putting plate heat exchangers in to protect boilers. It can. You've got your boilers sitting there. They're on their own little primary system with their plate heat exchanger, and then beyond that, on the secondary side, well, if it's an old, dirty old system, then we'll find it doesn't matter. Your boilers are protected by the plate heat exchanger. Air duct separators as well, and also strainers. Very standard practice, I suppose, to put those type of things in. But other pointers as well on the side there, we talk about boiler primary pump, making a note of the make and model of the boiler pumps. Boiler pumps get changed a lot more than actual boilers themselves. So you see it so often that you go into a site and think, well, actually the pumps look good. The boilers are a bit knackered, but the pumps look alright. So it could be that you could utilise those existing pumps. So always make a note of the pumps, so you can get the curve of those pumps and just see if they'll be suitable for your replacement project. Obviously, the system itself, is it seal system or open vented system? Obviously, open vented is pretty old school. We don't really see open vented systems that much. In older buildings, yeah, we do. Normally, common or good practice will be to change that over to a sealed system. You could keep it as an open vented system, and there's boilers out there that are okay. Modern condensing boilers are okay on open vented systems, but there are modern condensing boilers out there that aren't. But there are every single modern condensing boiler out there is going to be okay on a sealed system. So again, if you don't change that, you're just narrowing down your boiler selection as well. But if it is an open vented system, you could have a big expansion tank. So what's the height of the tank? Because that will obviously then determine the pressure you're getting at the boiler. So it's a sealed system, we'll have a pressurisation unit. So again, what's the make and model of that? Because that can help if you are looking at replacing that. So seal system, you've got expansion vessels, what's the size and volume of that? The PRV size and location. Obviously there's also air vent as well, and the drain, we need a suitable drain there. The open vent diameter was worth making note of that. Obviously we need a suitable cold feed. But then the final point there, I think, is probably one of the most important points. When we're looking at a tall building and your boilers are in the basement, potentially you could have quite a lot of pressure on the boilers. So that's not an issue, because there's 2 ways around that. You either find a boiler that can withstand that pressure. Again, that can really narrow down your boiler selection, or put a plate heat exchanger. Because put a plate in, and again, your boilers will be sitting there on working a 2.5, 3 bar, where the rest of your system could be on 10 bar, or as in your secondary side. And we've now got plate heat exchangers in our product range, and those plate heat exchangers are raised up to 40 bar, so they can really take on a lot of pressure. And moving on from there, if this works, which it doesn't. So we've looked at everything really. We've looked at the how we get the boilers in and out, our ventilation, our fluid, our legislation, our water quality and whatever. We haven't actually really looked at the actual boilers that are there. So, would we look at a like-for-like replacement? I would probably say no. You would always want to look at replacing the boilers with something a little bit more modern, something that's going to potentially save the client money. But really, the questions we need to be asking is the adequate boiler provision adequate? Or sorry, is the current boiler provision adequate? I guess the client's going to be the first person that's going to tell you they're having problems with their heating. So we should be aware of that. Obviously, our boilers we've got there at the moment. What's the current boiler input and output? The number of boilers that are sharing that load as well. That's quite important because do we need to put the same amount in? The boiler type, make a model. And what I would say to you is, if you ever went to a site and you had no idea what these boilers were, there's no databases on them, you couldn't find anything on them. Take a few pictures, a few measurements or whatever, count the number of sections or whatever, and let us know. Because although we're ideal commercial boilers, we've got a lot of knowledge in other boilers as well. So it could be that we might be able to help you guys out when you're looking at that. Obviously, if it's a pressure jet boiler, we're going to have a burner on the front there. So what's the burner's make and model? The fuel type. Now, do you guys see much oil? I don't know. I mean, I know my experience is down in London, and oil is a bit buried down there. But obviously natural gas, LPG, oil. But so obviously just be aware of what the fuel type is. Obviously, the final point there: does the current boiler meet legislation? If it does, and they want to go like for like, then yeah, fine. But if it doesn't, obviously we're going to change it to something else. And then moving on a bit more about the actual system itself. Looking at the system itself, a lot of this we covered previously, but things like hydraulic bypasses and separation, we've spoken about plate heat exchangers. Obviously, there's other ways of doing that. Could be looking at like low loss headers, that kind of thing. Reverse return. Again, if you've got a bank of boilers, and we're looking at maybe one shunt pump, or maybe a twin head shunt pump going over maybe 3 or 4 boilers. If you do it reverse return, because then you'll get your guarantee, or you'll get the correct flow across each of the boilers. So if we're looking at a bank of boilers and we're putting a shunt pump on the back of each boiler, then you wouldn't have to go reverse return. So because you're going to get the correct flow rate across each of those appliances. See, the header and system configuration we've kind of already covered. Also, because now we're probably looking at putting a condensing boiler in, we need to be able to drain that condenser away to a suitable drain point. Hopefully in the plant room there will be a drain or a sump or something that you can drain that away to. If you haven't got it, it's not the end of the world, because we can supply you a condensate pump, and that pump will pump the condense away to a suitable location. But you want to try and avoid that, I suppose, because again, it's another moving part in the boiler house, which potentially could go wrong. And moving on from there, obviously suitable cold main, so we need one of those. Water flow proving switch fitted, is there one? Pressure relief valve. Circuit temperature flow and return temperatures and required delta T. I suppose kind of almost go hand in hand together. So I think if you're looking at an older system, chances are that system will be maybe 11-degree delta T, sort of 82, 71. Now, if we're putting in condensing boilers, those boilers are never going to condense at 82, 71. But we don't want to start looking at we want to start changing the flow and return temperatures in our system to say 70-40 or something, because then we know our boilers are going to condense. If you do that, then you know your heat emitters on the other side aren't going to work because they're all sized on 11 degree delta T and that higher flow temperature. So what I would say is that keep your secondary side on 8271, but then maybe put your condensing boilers in there, maybe a low loss header, keep the primary side on a 20 degree delta T, secondary side on 11. You could put the condensing boilers in because we've got certain boilers, condensing boilers, that are okay on an 11 degree delta T. They can work, it's not a problem. But the problem you have is that when we're looking at older boilers, waterways were a lot larger. So when we're looking at sort of narrower delta T's, we're looking at a higher flow rate. So what it means is we're trying to, on a larger waterway, we're putting that water through there at a higher flow rate. It's not a problem, we can use a smaller pump, it gets through there. There's not a great deal of pressure drop through the boiler. Put a condensing boiler in, for modern boilers to be as efficient as they are, we've had to reduce waterways, the size of the waterways. So now what we're trying to do is we're trying to put the same volume of water at the same flow rate through a smaller hole, essentially. So what that means is we now need to use a bigger pump because we've got a higher pressure drop. So we're now having to put a bigger pump in. And is that really the most sort of efficient way of doing it? Plus as well you can get potential problems with noise because we're trying to put a higher velocity through a smaller waterway. So really I would always say that if you can keep your primary side on a 20 degree delta T, keep those flow rates down, with your secondary side on 11, then you'll get around. Obviously your boiler thermostat, the setting, the minimum maximum setting of the current boilers and the boilers you're proposing to put in. And the circuit types, I suppose we haven't really spoken about circuit types, are we looking at what we're serving? So are we serving constant temperature, variable temperature, domestic hot water, that type of thing. And then moving on from that, look at the controls. Older systems, you're going to have pretty antiquated controls, I'm pretty damn sure. I think you'll be fairly lucky if you went into an old plant room and you're going to have lovely new BMS systems sitting in there. If you have, brilliant, the boilers can just hook up to the BMS system, the BMS can take care of everything. But I suppose really just be aware of what that client's after. If they do want to look at putting a new BMS in, then yeah, great, let's go for that. But it could be that maybe they don't want to look at that, and they want to look at, maybe the boiler manufacturer supplying a full, we can't supply full-blown BMS systems, but we can supply control systems that can do a lot, control other zones and that type of thing, so to improve the efficiency of it. So really, do we want to start looking at putting boiler sequencers in? Obviously, if we haven't got BMS and we're putting a bank of boilers in, we'll put sequence controls in. I'll be looking at room temperature sensors, programmable room sensors. If we want weather compensation, obviously we're going to have to put external air temperature sensors in. If we've got calorifier there, and our boilers are serving that calorifier, then we're going to need a domestic hot water sensor going back to the boilers to accommodate that. And then finally, we put fault signal, run signal, high temperature signal, burner on signal. I don't know if anyone has seen or has been asked if they can, a boiler, maybe they're putting a new boiler in, they want more information to actually come from the boiler, so things like hours run and I don't know, real-time gas consumption, that type of thing. I don't know if anyone's seen any of that. And the reason I ask is because I got asked a question a few months ago from a consultant. He designed the system, the boilers have gone in, the boilers are running fine, no problem at all, they were running alongside a CHP. The CHP was like a Formula 1 engine, it had sensors all over the and the building manager could dial into his CHP and he could look at the CHP on his screen, he could see exactly what the CHP was doing. But he wanted to do the same with the boiler, and I was asked this question: have we got anything that you can do? So he can. Well, he's got BMS there. Surely the BMS is enough. But he wanted a lot more information coming out from the boiler. Anyway, so I went back to our R&D guys. I said, "Look, is this something we're looking at?" And they said, "Well, we don't really see there's a market for it, to be honest, not on a commercial scale." And that's the reason I asked, is because I've been asked that question once, and I put it out there when I do present at CPD just to see if I get any information. Anyone says whether they've seen this, and you're kind of
fault signals would be good.
Yeah, exactly. And you're kind of echoing what most people are saying. Yeah, all of our boilers will the boilers will basically sit there and say, I'm on standby, or I'm running, or I've got a problem. And that's basically all you really need to know. And that's what all of our boilers, they will give that information back to the BMS. I think as well, it's kind of a safety thing as well, because what you don't want to be able to do, if there's a problem with the boiler, you don't want to sit there and remotely try and reset stuff or try and fiddle around with it, because you don't know really what's going on in the plant room. It's because it's a safety thing, you should go down there and physically stand in front of it. Anyway, moving on from that, domestic hot water, I won't dwell on this too much because we are not a water heater company. We manufacture commercial boilers, so I'm probably not best versed to tell you exactly what you want to be doing when you're replacing direct flight gas water heaters. But I think really, just take from this slide, I think if your client needs you to look at the domestic hot water side, just be aware of how it's being served. And if it is being served by direct fire gas water heaters, essentially they're a boiler. So everything we've gone through with the boiler, you will have to go through with the water heaters as well. Ventilation, fluid, legislation, that type of thing. But really, I suppose the first point there is the current provision adequate. Therefore, the first people are getting to tell you that we're running out of hot water. But how are we producing the hot water? So direct fire gas water heaters, instantaneous plate heat exchangers, semi-instantaneous plate heat exchangers, that type of thing. But just a few other pointers there. Like I said, I won't go into that in too much detail. I'll just say we're a boiler manufacturer, not a water heating manufacturer. And then moving on from there, I suppose really looking at, when we are looking at domestic hot water, things like system checks. So, looking at the direct or the domestic hot water load, is it adequate? Do we need to start looking at putting a dump load in? When we talk about dump loads, we're talking about at peak time. So take, for example, a hotel. If it's a business hotel and you've got people getting up between 6 in the morning and 7:30, you've got an hour and a half period where you're going to have a lot of people sharing. So it could be that we might need to start looking at putting in more sort of stored water, essentially. And then going on to the fuel again, we've obviously looking at the fuel detail itself. Obviously, once we've ascertained whether we're looking at LPG, natural gas, oil, or whatever, we need to look at, if we're looking at gas, for example, we need to be aware of what the gas meter size is. If we're looking at oil, be aware of what the oil is. What oil is the boiler running on? So is it 35 second, 28 second biofuel? If we are running on oil, what's the size of the tank? If it's dual fuel, so really, I'm surprised that even down in London, we still see a lot of dual fuel, gas and oil. We're doing some work with the Metropolitan Police, and one of their policies in all of their specs is that they want dual fuel. So we still do that. So it is an oil shut-off valve fitted, and the fuel delivery access as well. So, because what could be maybe how we were delivering the fuel for the past 25 years now, may not really be the best way of doing it. We might need to look at changing that. And then really looking at the gas, which I suppose probably a large proportion of the projects you look at gas. So a few pointers there. Is it visibly marked and bonded where necessary? Is there a gas shut-off valve in the plant room? Now, I always thought it was mandatory. You had to have a gas shut-off valve in the plant room. And somebody argued this the other week and said, well, actually, no, you don't need it in the plant room. There needs to be one outside the building. That's the mandatory side. It's just it's a recommendation to have it in the plant room. But I would always thought it would be, if it's a recommendation, I would say it's good practice to do so. Where it's sleeved where necessary. Obviously, what's the diameter of the gas pipe work and its total length, and the quantity and variety of fittings. I suppose again that all goes hand in hand, because you think, what's the diameter of the pipe work? How many twists and turns have I got? What fittings have I got there? They're all going to add to pressure loss within the gas pipe work. And what I would always say is that older boilers are far less sensitive to gas pressures than newer boilers. And what you don't want to do is walk into that plant room and think, well, okay, my boilers are sitting there, they're working fine, the gas pressures must be fine. I'm not going to fiddle around with the gas pipe. And then you take those boilers out, put some nice shiny new condensing boilers in, and all of a sudden we've got gas pressure problems. Chances are those boilers have been sitting there running on 10 bar gas pressure. Also 10 millibar gas pressure, where your new boilers now, probably minimum 15 or 17 millibar. So So just be aware of that and make sure it's adequate for what we're proposing to put back in. The pumps, we kind of touched on pumps really, but I want to say about using existing pumps again. Can we use existing pumps? I mean, two things on the pumps. I would always say, if you are looking at using those existing pumps in that plant, two things: can they overcome the resistance over the heat exchanger, and can they give the required flow rate across that heat exchanger on the new boilers, obviously. If they can do that, then there's no reason why you can't use those pumps. Obviously, system type, again, we've kind of gone over this earlier about seal system, open venting system. There's just some diagrams there on which is which. As I said, open venting, pretty old school. You really want to switch over to a sealed system. But as I said earlier, if it is an open venting system, you can keep it. It just really narrows down your boiler selection. And then really, I suppose, replacement considerations. First one's legislation. We just got to make sure we meet current legislation. If we don't, all that's going to happen is we have an engineer that go there and slap a sticker on it and say, no, sorry, we can't go in for this. But also being able to get get the boilers positioned and get the adequate clearances around them, because we've got to be able to service those boilers. But really, things like legislation and you say, for example, flues. I touched on flues earlier. It could be that you go to your site and you say, well, actually, I know they've been fluing the flue out of that wall for the past 10 years, but we've now got a building opposite, which has got openable windows, for example. Actually, no, we can't flue out there anymore. We've got to take it up through the building or up through the wall. And your building occupier or owner may just think you're being a bit of a jobsworth. But it's so important that we meet. As I said, if we don't, then the system just gets shut down. And finally, looking at commissioning, I suppose us, along with every other boiler manufacturer, whoever requests commissioning from us, be it contractor or whatever, we will then send them a tick sheet essentially. And what that tick sheet is, it's a requirement of what we would expect them to do prior to us going to site to commission the boilers. It safeguards both of us. It safeguards us because we know they've done everything that we would expect them to do prior to us doing the commissioning. It safeguards them as well, because they then know that they've done everything that we want to say. So really, it's peace of mind for them, it's peace of mind for us. So we know when we get to site, everything's done, there's going to be no worrying about abortive visits or anything like that. But what we would say is, us from a boiler manufacturer's point of view, what best practice to do prior to commissioning. Method statements, we spoke about that earlier, method statements and risk assessments. Again, that's always good to go all the way down the line to the commissioning engineer. So if you can do that, then he knows what he's up against before he gets to site. Is the plant room in a clean state? All these things seem pretty obvious, but you'll be surprised so many times we go to site. And I had an engineer sent me a picture a few weeks ago of a site he went to go and commission, and he wrote dust on top of the boiler. He said he just can't do it. The plant room was so dusty, and it just wouldn't have been good for the boilers for them to be firing in that environment. Make sure the control valves are present and correctly positioned. Make sure there's electric to everything. Make sure the system's filled, so we've got water in the system. All sounds obvious, but these are all points that we have come up against, and we've been expected to commission boilers when we have no water in the system. Make sure the fuel system's purged, PRV set and active. Make sure we've got flue installed as well. Control systems are operational, the boiler room ventilation is proven and available, and the boilers have been initially fired. And then obviously once that's all done, and everyone's happy with all that, we would then go to site. Amongst other things, but the main things we would do when we commission the boilers, we take high low combustion readings, we check the working gas pressure to make sure we've got no gas pressure problems, we check the flow and return temperatures and the differentials, so we're checking the delta T's, and then we're checking the flue performance, just to make sure the flue is performing correctly. There's no things like unburned gas or anything, or any products of combustion coming back down the flue. And then once we're happy with that, we would issue a commissioning report, we rubber stamp it, that then goes to the client, or goes wherever he wants to see it, and then essentially that is your replacement from start to finish. So that is, and if anyone knows you should know actually, like this, I show this to people in London, and I get a lot of sorry? Yeah. You probably imagine a few people photograph. Well, the story behind it is, I don't know if you know, but it's more on the domestic side, but I always finish with this slide. That is actually a domestic boiler, or a man dressed up as a boiler. We did it the season before last, and we've done it this season, I think we'll do it next season as well, where, so more so on the domestic side, they've sponsored West Brom. And I think it was one of the first games of the season I think it was the first season we sponsored them. First game of the season, it was a packed crowd, and they unveiled their new mascot, and this guy come running out. And I don't know if anyone's seen it, but you can look at it on YouTube. And this guy was just running around doing all this stuff. And everyone, and not even just the away fans, but I think everyone was just throwing abuse at this. And just couldn't get. You can imagine your average football supporter will look at that and think, now why the hell is our new mascot boiler on legs? But I think it's been more so on the marketing side. It's been a really good marketing side. But anyway, thank you for listening. And yeah, any questions or queries or anything? Good. Cool. Well, thank you for coming. It's good to have a good turnout. Cheers.